Now, let's discuss on certain types of functions. Here in this chapter, we are discussing mainly on two types of functions, namely 1-1 function. The first one is 1-1 function, which is also called as injective function. So, the first function which we are discussing is 1-1 function, which is also called as an injective function. The second one is many-one function. Many-one. Now let's see in detail what is 1-1 function and what is many-one function. Okay. So I shall draw a arrow diagram. Okay. Let f be a function from a to b. Corresponding to x1, what will you have? F of x1. x2, what will you have? F of x2. And fx1 maps under the function f to give what? F of x1, and x2 gives f of x2, and so on. What does that mean? Corresponding to every element in this set A, there is only one image in set B. For every element in A has only one image in B. Such a function is called as a 1-1 function. Such a function is called as 1-1 function. Now, here to understand many-one function, again I say f is a function from the set A to set B. Right? Here I shall give you an example. Here the function f is equal to x square. Okay, the function f of x is equal to x square, and the set A is equal to -1, 1, 2 and -2. I'm just defining for a small set. Now B is equal to set 2, 4. Okay, I shall write one more, which is 1. 1, 2 and 4. So what can I say? -1, 1, 2, -2. These are the elements in set A, and B has the elements 1, 2 and 4. Under the function f of x is equal to x square, -1 gives you what? -1 square, which is 1. 1 square, which is also 1. Right? 1 as well as -1 is mapped to where? 1. Now 2 and -2. 2 square 4, -2 square is also 4. Here what happens? Many elements means what? Here 2 and more elements. More elements are not here. 2 elements. 2 elements is mapped to a single element here. Right? 2 elements or more elements it can be. Many-one. Many of the elements in the domain of the function is mapped to an element, a single element here. So, if a function arises in this form, it is called many to one. Many elements in the domain is mapped to one element here. So, many to one. So, this is many-one function and this is 1-1 function. Now, this 1-1 function can again be classified as an onto function and an into function. Onto function is also called as surjective function. Surjective function. Now what is onto, or when is a function said to be onto? Now here I have two sets A and B, and f is a function from A to B. Now every element of B, see elements in B, has a pre-image in A. Has a pre-image in A. I repeat, every element in B has a pre-image in A. If so, this function is said to be onto. The function is said to be onto if every element of B is having a pre-image in A. Now, coming to into functions. Again, if f is a function from A to B, and here every element of B is having a mapping, but still if there is an extra element here which doesn't have a pre-image in A. Right? Here every element had a pre-image. Here there are elements in B which does not have a pre-image in A. Such a function is said to be an into function. So what is an onto function? Onto function is a function where the set elements, all the elements in set B is having a pre-image in A. It is onto. Into means what? There are still more elements in B which do not have a pre-image in A. Okay, so here I can say this is 1, 1 onto. If it satisfies 1, 1 and ontoness, I can say that the function is 1, 1 onto. It can also be 1, 1 into functions. Okay, similarly, many one function also is classified into 2 as it is onto. Onto, another name is surjective function. Surjective function and into functions. Into functions. Since it is many one, I have two sets, what? A and B mapped under the function f. Right? Now here you have seen, it's already many one function. I have an image like this. Minus 1, 1 and the image here is 1 under the given function. Suppose this B doesn't have a 2 there. The B doesn't have a, correct, the B doesn't have a 2 there. So here you have 2 as well as minus 2. Both are mapped to where? 4. Okay. Now this function is an onto function. Every element of B. Now here when I define B, B is only having what? Set 1 and 4. Okay. I have taken that 2 also. Okay. Here B is having 1 and 4. A is very same as that. Minus 1, 1, 2 and minus 2. Okay. So every element of B is having a pre-image in A, right? So this function, many one onto function. Now, likewise into function, what will happen? If a function is like this, that is, you have two sets here, A and B, and there is a function f from A to B, and you have minus 1, 1, 2, minus 2, and as in B, 1, 2 and 4 you have 1 and 2 is having a image there, 2 and minus 2 has the same image here, 4, but still there is an element B which is not having a pre-image in A. So such a function where there are elements in B which is not having a pre-image in A is called as an into function. Into function. Okay, if every element of B is having a pre-image, it is called as an onto function. Am I clear? So these are the different functions. 1, 1 onto function, 1, 1 into function, many one onto function, many one into functions. Okay, understood? Okay. So now we have discussed on 1, 1 functions, many one functions, onto function and an into function. Now let's see what is a bijective function. That is what more important to us. In this particular chapter, in our syllabus, what we discuss more is a bijective function. Now let's see what is a bijective function. I hope what is 1, 1 function and onto functions are clear to you. Okay, so now let's see what is a bijective function. A function which is both 1, 1 and onto is called as a bijective function. Now this 1, 1 function means what? What was 1, 1 function? This is also called as injective function. 1, 1 is also called as injective function. So 1, 1 function or an injective function, what does it mean? Every element, for all elements of X that belongs to the domain of the function, there exists a unique what? Image. Where? Image in the codomain of the function. Am I clear? For all X that belongs to the domain of the function, there exists a unique image in the codomain of the function. Okay, so in this case it is called as a 1, 1 function. Or I can say that f of x1 equals f of x2, where x1 and x2 belongs to the domain of the function. For x1 comma x2 belonging to the domain of the function, if f of x1 equals f of x2, what can I say? When will f of x1 equals f of x2? For x1 and x2 belonging to the domain of the function, can I say that x1 is equal to x2? Only then this one-oneness holds. Now this is the algebraic expression of a one-one function. What does that mean? For every value of x1 and x2, the image that you get in the codomain is a unique one. No two elements in the domain of the function is having the same image. Okay, that means for f1, f of x1 and f of x2, where does this f of x1 and f of x2 comes? In the codomain. That is, see, if I draw a arrow diagram, okay, this is the domain of the function, this is the codomain of the function, and this is mapped under the function f, and here you have x1, here you have x2, okay, and here you have f of x1, right? When f is applied on x1, you get f of x1, and when f is applied on x2, you get f of x2. Okay, if this f of x1 is equal to f of x2, what does that implies? This implies x1 is equal to x2. That is how I prove one-oneness. This is how I prove one-oneness. For example, say f of x is a function given by 2x plus 3. To check whether this function is 1, 1, I take, let x1 comma x2 belongs to the domain of the function. Then f of x1 is equal to f of x2. Right? Let x1 comma x2 belongs to the domain of the function such that f of x1 equals f of x2. What does it means? 2x1 plus 3 is equal to 2x2 plus 3. Am I clear? Correct? So, this 3 and this 3 get cancelled. 2x1 is equal to 2x2. Further 2 and 2 cancels, which implies x1 is equal to x2. What does this ultimately gives me? This function fx is equal to 2x plus 3 is a 1, 1 function. Now here I have not defined the set. I have just taken the domain of the function and the codomain of the function. I can say the function is defined from R to R. Okay, for a function f defined from R to R given by f of x is equal to 2x plus 3. This is how I prove that the function is 1, 1 or the function is injective. How do I prove? I take two values x1 and x2 belongs to the domain of the function such that f of x1 equals f of x2. See here, f of x1 equals f of x2. Right? When these two are equal, automatically which two are equal? x1 and x2 are equal. Okay? f of x1 is equal to f of x2 implies x1 is equal to x2. So this is how I prove for one-oneness, 1, 1 function, or that is an injective function. Now let's see what's an onto function. Onto functions are also called as surjective functions. Onto functions are also called as surjective function. For example, I take a function y is equal to f of x, where f of x is given by 2x. f of x is given by 2x. Okay. Now this is from the function f is from R to R. Okay. The function f is from R to R. Okay. So I have y is equal to 2x, right? Onto means what? For every set, I can now go back to the set A and B, just to make you recall what we had already discussed on onto. Every element of B must have a pre-image in A. There mustn't be any element in B without a pre-image. Okay? If so, the function is said to be onto. So in this B, there mustn't be any element which doesn't have a pre-image. So here it is from R to R. Okay. So let me draw y by 2 is equal to x. Y by 2 is equal to x. Now for any y value that you take, from where? From this R. Can you find a corresponding x value? Yes or no? Yes. Which is there in this R? isn't it? Now, let me see here. Okay, x is equal to y by 2. How do the graph come? X is equal to y by 2. This is how the graph goes. Right? This is how the graph goes. So here, if you look at corresponding to every y value, you can find a unique x value. Correct? Corresponding to every y value, you can find a unique x value. Got it? So that means this is an onto function. No two values, none of the values in y is left just like that. For every value that you take here in the set of R, you can find a x value. For every y, there exists some or other x values on this graph. Right? If so, this function is said to be an onto function. Now here, this x, I can write it as an expression of y alone. Right? If so, I can say that this is an onto function. Now, from this graph, you will understand this in fullest. X is equal to y by 2. So this is how the graph comes. This is the graph. This is the line. X is equal to y by 2. Okay, this is equal to y, x is equal to y by 2. And for every corresponding value of y, you can find a x value corresponding to this point here. If you look at this for the y value here, you can find an x value here. So for this function where x is equal to y by 2, I repeat, for every value of y in the codomain, there exists a pre-image in x. Now this happens for the value of f, the function from R to R. Suppose the same function f is defined from n to n, where n is the set of natural numbers. Okay. Now, when you take this n to n, when I draw this arrow diagram, I have 1, 2, 3, 4, 5, etc. Okay. Now, y is equal to what? 2x. Okay. So this 1 into 2, that is 2, 2 into 2, 4, 3 into 2, 6, 4 into 2, 8, 5 into 2, 10. 1 is mapped to 2, 2 is mapped to 4, 3 is mapped to 6, 4 is to 8 and 5 is to 10. But here, if you look at, still you are having 1, 3, 5, 7 and 9 without pre-images. Got it? Now can you say this function to be onto? Can you say this function to be onto? No, because there are elements that is left in this codomain without a pre-image. Without a pre-image. If so, if there are elements without pre-image, then this is not onto. This is not onto. But if you look at 1, 1, yes, it is 1, 1. It is 1, 1, but this is not onto. So for a function which is both 1, 1 and onto is said to be a bijective function. A function which is both 1, 1 and onto is said to be a bijective function. Okay, or 1, 1 onto function. So let's see another example where it is both 1, 1 and onto. So I hope this is clear. Just go through this once again.